Hello, Sahanya. Hello. Hello, Sahanya. Hello. Hello, Sahanya. Hello. Hello, Sahanya. Hello. Hello, Sahanya. Good evening. Hello. Hello, Sahanya. Hello. Are you able to hear me? Hello, Sahanya.
Hello, mom.
Hello, Sahanya. Hello.
Hello.
Hello. Today I will be taking the class. Ma'am is not there, so I will be taking it. Hello, Sahanya.
Okay, sir. Okay.
Okay. So I will be continuing with that light topic. Okay.
Yeah, sure.
Okay. So I think ma'am had completed up till the definitions related to lenses. Okay. So PPT has been displayed. Are you able to see it? Yes. Hello. You see the PPT over there? Hello. Hello, Sahanya. Hello.
Sir, your voice is very low.
Now, this is 1 minute. 1 minute. Can you hear me now?
Yes, sir.
Okay. So you can go through. Are you able to see the PPT?
Yeah.
Uh, okay. So ma'am had covered, I think, up to the terms in the lenses. She has covered na that part. Yes.
Yes, sir. Yes.
Not terms in the lenses. Now is it clear?
Yes,
Why is
sir.
it clear? Okay. 1 minute. We will begin. Mhm. See, so ma'am has already covered up to the terms in the lenses. Okay. So up to here, ma'am has covered. So next, we will be continuing with this part. Okay. So terms in the lenses, ma'am has covered. Okay. So this part has been covered. Next, we will be discussing the next part here. Okay. So the first point in terms in the lenses is center of curvature. So the center of actual glass sphere of which the lens forms a part. Okay. So you already know na these definitions, Sahanya.
Yes, sir.
Uh, so just we will revise this and then begin with the next part. Only a small concept is remaining. Okay. So see, actually, you have seen a football.
Yes, sir.
Uh, so football or a marble. Okay. So what they do is when they want to form a concave lens, they will cut this portion, okay, of a sphere. Okay, so sphere, it is a circular object. So when you cut this part, whatever this portion you are getting, okay, this portion is called as this will form the concave lens. Okay, and actually this is the circle. Okay, So here the center of the actual glass sphere. Okay, this is called as the center of curvature. Okay, this point C, whatever I am showing here, is called as the center of curvature. Okay. Next we have principal axis. So principal axis,
Yeah,
it is
the
a
two
ah,
spheres. When yeah, the
no,
when the
it
two
is the
spheres
it
are
is
part of the lens.
no, it is a line. Okay, it is a
Yeah,
line.
imaginary line with
Imaginary
joining the
line is
center of the both of the spheres.
both of the spheres. Okay, is called as the principal axis. Okay,
Axis.
and then the third point over here is principal focus. Okay, so principal focus, it is a point on the principal axis where the light rays parallel to the principal axis meet in the case of convex lens. Okay, in case of convex lens, what will happen here is, okay, so if you consider a convex lens, okay, so whichever lines are parallel to this principal axis, okay, see this is the principal axis, PA. Okay, this is the principal axis. So whichever lines are parallel, rays are parallel, they will appear to meet at one point. Okay, this point is called as the principal focus. Okay, it is called as the principal focus. And then we have optical center. Optical center is the center of the lens. Okay, it is
Yeah,
the
it's
center
like the point within the
uh,
sphere.
within the lens, not within the sphere. It is
Yeah,
a
sorry,
point
lens. Yeah.
uh, within the lens through which the principal axis is passing. Okay, so this point is called as the optic center. And then the last definition is focal length. Okay, so the distance between the optic center, and if I consider this as the principal focus F, then the distance OF is called as the focal length. It is called as the focal
Focal
length.
length.
Okay, so all these five terms are essential. The
Okay.
first term is center of curvature. Second is principal axis. Third one is principal focus. Fourth one is optical center, and fifth one is focal
Focal
length.
length.
So if you know all these 5 points, then we can understand the ray diagrams. Okay, we can understand the ray diagrams. So before going to the ray diagrams, we have three important points. We need to know. Okay, so we will discuss these 3 points. These 3 points help us in drawing the lines. Okay, whatever the lines or the rays, whatever we consider, okay, can be these points will help us to draw these rays. Okay, so one by one we will discuss. So there are three types of rays here. Okay, we will discuss it. Okay, so there are three types of rays. So one by one, try to understand. So these are the three types. Using these three types, we will be discussing the ray images. Okay, ray diagram. Okay. So the first one is the line which is parallel to principal axis. Okay, the line which is parallel to a principal axis. So when such rays are passing through a lens, okay, the lines which are parallel to which axis? Parallel to which axis? Shivanya?
Yes, sir.
The rays which are parallel to principal axis. So if we here, this is the principal axis PA. Okay, and these are the two parallel rays which are parallel to which axis? Principal axis. So whenever the lines are parallel to principal axis, they pass through the principal focus. Okay, they always pass through F. That is the principal focus. Okay, so this is the first type of ray. Okay, parallel rays. Which rays? Parallel
Yes.
parallel rays. So these parallel rays, okay, these rays are parallel to which axis? They are parallel to a principal axis. They are parallel to a principal axis. Okay, so this is the first point. If the rays are parallel to principal axis, then always they will pass through the focus. Okay, so whatever the rays are coming from the object, suppose if this is the object here, okay, if this is the object, AB, this is the object, this is the object, then always it will pass through the principal focus. It will pass through the
Principal
principal
focus.
focus. Okay. So this is the first type of ray. Okay. You take a book and write down the first type of ray.
Okay.
Okay. one sentence I'll dictate because these three types of rays are very important. Okay, write down first one. The rays which are parallel to principal axis. The rays which are parallel to principal axis.
The rays which are parallel to principal axis
Principal axis pass through principal focus.
pass through principal
Focus.
focus.
Principal focus. Okay. So this is the first type of ray. Okay. So okay. So which process is taking place here? Reflection is taking place or refraction is taking place?
Refract.
Refraction is taking place. Okay.
Yeah.
So when they are passing through the lens, refraction is taking place. Refraction is taking place means bending of light is taking place. Okay. So it actually they are parallel, but after they pass through the lens, they pass through the principal focus. Okay. So that is the first set of line. Okay. Now the second set of line is exactly reverse. Okay. So see, this is the principal axis. This is the
Yeah.
principal axis. This is the lens. Okay. This is the lens. Okay. And this is the focus. Okay. Principal focus. This is the principal axis. Okay. So now see any ray which is passing through principal focus and touching the lens. Okay. Or passing through the lens. So when it is coming through what? Principal focus. After the refraction in the lens, it will go parallel to the principal axis. Okay. It will move parallel to principal axis. So any ray which is coming through principal focus and touches the lens, after refraction, it will go parallel to principal axis. Okay. So this is exactly opposite to the first ray what we discussed. Okay. Hello.
Yes, sir.
Some disturbance was there.
Yeah, sir. That's like our neighbor. Sir.
Okay. See, pay attention. So this is the second type. So the second type of ray, what it is doing? If a ray is passing through a principal focus, then after refraction in the convex lens, it will move parallel to the principal axis. Okay. So write down in your book. Second type, type 2. Type 2, you write. Type 2, second type. So in second type, what you have to write? If a ray passes through principal focus, principal focus,
Principal focus.
then after refraction in the lens, then
After
after refraction in the lens, it emerges parallel to principal axis.
emerges parallel to the principal
Axis.
axis.
Emerges parallel to the principal axis. Okay. So see the first ray what we discussed and the second ray are exactly opposite of each other. So the first ray is what? If the ray is parallel to principal axis, after refraction it will pass through principal focus. The second ray is if the ray is passing through principal focus, then it will emerge out parallel to principal axis. Okay, understood?
Yes, sir.
Both the rays. Now the third type we will be discussing. Third type is okay, so the third type is very easy. Okay, so in the third type, to discuss the third type, we require the definition of optic center now. Okay, please pay attention. This is the third type 3. In the type 3, we are considering the principal axis and the lens. Okay, and the lens. And we know the center of the lens is called as what? It's called as optic center. Okay? So if a ray is passing through optic center, okay, then it will pass through it directly. There is no bending of the light ray. Okay, so there is no bending of the light ray if it is passing through optic center. So whichever ray is passing through optic center, it will move undeviated. Okay, so there is no bending taking place. Okay, so when it is passing through the optic center, there is no change in the path of the ray. Okay, this is the third one. Okay, a ray of light passing through optic center goes undeviated. Undeviated means without bending it will, okay, it will not bend, okay, it will not bend, it will go as it is, okay. Understood, Sahanya?
Yeah, yes, sir.
Yes, so these are the three types. So using these three types, we will be discussing the ray diagrams. So write third point also, you write there in your book.
Okay.
Third point, third point you write down. The third point is a ray of light
A ray of light
passing through the optic center.
passing through the optic center, yeah,
Center goes undeviated.
goes where?
Undeviated. Undeviated. Undeviated.
Undeviated.
Deviated. Undeviated.
Yeah.
Yeah. Undeviated means without any bend. Okay, without any bending. It will go out without any bending.
Bend.
Okay. So see the three types we have discussed now. So using these three types, we can understand the ray diagram. Okay, we can understand the ray,
Ray.
ray diagram.
Okay.
Okay. So,
Yeah.
first four ray diagrams are for convex lens. Okay, the first four. Out of that, the three are being here given in the PPT. So we will discuss one by one.
Okay.
Try to understand. Very important. If you have understood the rays, it's very easy to understand this. Okay.
Okay.
Okay. So see, the first type is, see here you need here actually three terms are there in the column. First one is position of an object, then ray diagram, and then image. Okay. So
Yeah.
position of the object, and then so one by one we will understand. So see first one, pay attention here. So to draw the ray diagram, you have two things. One is object, okay, and this object, the rays from the rays from the object will form of the form, okay, will be formed on the lens, and after whatever the rays are there, uh, they emerge out and they form a image. Okay. So object, lens, and image. Okay. So three things are required here. That is object, lens, and what image. Okay. So now first try to understand the positions here. Then you will get to know.
Okay.
Okay. One minute, pay attention. See, this is principal axis. Okay. And then this is the lens. Okay. This is the lens. This is
Yeah.
the optic center. Okay. This is the optic center. So here this is F. Okay. F
Sir,
is
will these diagrams come for exam? Like just asking. Is it ever?
uh, sometimes they occur. They ask you to only they will in the question they will ask you about, they will give you the position of the object, and based on that you need to draw the diagram.
Yeah. Okay.
And
Okay,
then
sir.
you need to discuss the position, nature, and size of the image. Okay, so these diagrams are very important. So see focus. Okay, and exactly double the focus will be 2f. It will be 2f. This is the optic center O. Then on the same on the RHS again you have f. Have
Okay.
2f. Okay, understood. In
Yes,
some
sir.
books, instead of 2f, they make use of c. In your textbook, what they have made use of C? Whether they have made F, 2F or C.
So like actually today I couldn't bring my textbook because the teachers like told that soft copies are easy.
Okay, okay. So in some books, they will make use of F, F, and 2F, 2F. Okay.
Yeah.
Or they will make use of F, F1, C1, F2, C2. Okay. The two types they will, I will let you know. So this is the lens. Okay. So this is the principal focus here. Okay. On the right side, this is the principal focus. On the left side and right side. Okay. Similarly, you have 2f. Instead of 2f, they in some books they write it as c. C denotes the center. Okay. So in some textbooks they may make use of f1, f1, f2, and then c1, c2. Okay. Understood?
Yes.
Don't get confused. Okay. C1 or 2f is both one and the same. Okay. C1 or 2f1 is one and the same. F1, F2 and FF is also same. Okay. So in some books they use F1, F2 or FF, 2F and 2F. Okay. Now see, pay attention here. Okay. So here four positions are there. The first position, okay. So see, to understand the ray diagram, I told you there is the object, first object. Okay. Then second we have lens, second is lens, and third it is image. Okay. So whatever the rays are there, they will be coming from the objects. Okay. So whatever the rays are there, these are called as the incident rays. Okay. These are called as the incident rays, and these rays come from the object. Okay. They come from the object, and they fall on the lens. Okay. They fall on the lens, and
Yes.
after they fall on the lens, they undergo refraction, and they form the image. Okay, they form the
Okay.
understood. So now whatever
Yes,
the
sir.
rays are there, these rays are coming from the object. They are coming from the object,
Object.
and based on the position of the object. Okay, you might have seen yourself in a mirror. Okay,
Yeah.
so when you try to go close to the mirror, you can see, means as it is, you can see yourself in the mirror. That
Yeah.
is, if you are very far from the mirror, you feel you are little bit short. Okay, or
Yeah.
it shows the smaller image. But as you go very close to the mirror, it will give you a very sharp and clear image. Okay.
Okay.
So same way, whenever the object is far from the lens, okay, the what you can say, the nature of the image is different, and when it is very close to the lens, the nature of the image is again totally different. Okay, so we will try to understand this one by one. So see, pay attention now. So see here in this figure over here. So see, when the object is beyond 2f, okay, where it is
Yeah.
very beyond 2f, then they say the object is at infinity. Okay, so the first location is say at infinity. Okay, so when it is beyond 2f. Next, beyond 2f. Okay, say here you need to understand the difference between infinity and 2f. Okay, so see, simple. I will tell you. Suppose this is the lens. Okay, this is the lens, is the lens. If this is f, and then this is what 2f. Okay, then infinity is a point which is very far from 2f. Okay, so 2f, suppose it may be 100 centimeter. Okay, it may be 100 centimeter, and then beyond 2f means beyond 2f, and that is at it may be just 20 centimeter away from 2f. Okay, it may be 20 centimeter. Okay, so infinity means it is very very far compared to 2f. Then we have at 2f. Okay, at 2f, the third position, and then the fourth position we have. You can see there in the next slide it is. Okay, later we will see it. Okay, so the fourth it will be on f. Okay, on f. Okay, so four types are there. So one by one we will understand now. It's very easy to understand. Just we need to understand the figures.
Okay.
So you understood four positions. The
Yeah.
first position is at infinity, when the image is at infinity. So infinity means whatever the rays are there, they are coming from infinity. Okay. So see here in the first image you can see the first image. You can see that the first image. Okay.
Yeah.
In the first image you can see four lines are there. One, two, 3 and 4. So see these four lines, they are coming from a object. Okay, they are coming from a object which is
Oh, yeah.
placed at infinity. Okay, and you can see all these rays are what parallel to the principal. They are parallel to the principal axis. Okay, so according to the first condition of the ray, okay, the lines which are parallel always after passing through the lens, and they will pass through the focus. They will pass through the
Focus.
focus. Okay, so you can see whatever the rays which are parallel after passing through the lens, they are passing through the focus here. Okay, you can see that it is passing through f2. It is passing through f2. Yes, sir. So f2 is nothing but the focus. Okay, f2 is nothing but the focus. Okay, it is the principal focus. So here, which rule we use? The first rule. The rays which are parallel to the principal axis, after passing through the lens, they pass through the principal focus. Okay. So wherever these two rays are meeting, or more than two rays are meeting, that is the place where the image is formed. That is the place where the image is formed. Okay. So you can see all these four rays are meeting at F. Yes.
Yeah.
So here the image is formed. Okay. Here the image is formed. Okay. So object, you can see it. Image also you can see it. Okay. So the image, this image, what you can do, you can easily see it, and you can catch it on the screen. Okay. Means you can see it on the screen. Okay. Such images are called as real images. What they are called? Real images.
Real images.
Real images. So if you have been to a theater, okay, whatever the rays are there coming from a disc, they are projected on a screen. Okay, they are projected on the screen. Meaning is the image is captured on the screen. Okay.
No.
So whatever the images you see, those images are called as real images. They are called as which images? Real images. Okay. So if you see, just if you see from where the light is projected in the theater, it will be coming out through a lens. It will be coming out through a lens. Okay. And once it comes out through a lens, it can be projected on the screen. Okay. So such images are called as what? Real images. Okay. So here we need to understand now how the image will be. Okay. So see there, first we have to tell the position of the image. Okay. So see here in the figure over there. The position of the image. So the position of the image is at f2. It is formed at principal focus. Next, the nature of the image, it is real and it will be inverted. Okay. So if the object is in this pattern, then its image will be formed in reverse pattern. Okay. So they are saying the nature is real and inverted. And then the third one, highly diminished. What do we mean by diminished, Sahanya? Highly
Um.
diminished means very small. Okay. Very small.
Oh, okay.
Okay. So
Yeah.
suppose if the object is 100 centimeter in length, then its diminished image will be just 10 centimeter. Okay. Understood? What's your
Yes, sir.
height? What is your height?
150.
150 centimeter. Okay. So if your diminished image is formed, it will be just 15 centimeter.
Oh,
Understood. So
yeah.
highly diminished means very small. Okay, very small. Okay. So see, it is so three things are there here. You need to know. We need to know the position, nature, and size. So position is at f2. Nature is real and inverted, and size is very small. Okay. So
Yeah.
we discussed about the object, then we discussed about the lens, and then we discussed about the what image. Okay. OLI, object, lens, and image. Okay.
Yeah.
So the first formation we discussed when the object was at infinity. Now second type is beyond 2f. Okay. See here the second type is beyond 2f. So you can see this AB is the object. AB is the object, and from AB, two rays are emerging. One is parallel to the lens. You can see there is a lens, a ray which is parallel to the lens. So whenever the ray is parallel to the principal axis, it will pass through F2, that is the focus. Okay, it is passing through F2. And see, there is a second type of ray which is passing through optic center. Okay, so we discussed when a ray is passing through optic center, it goes out without bending. Okay, so it is moving in the straight direction. And see, you can see the first ray, the ray number one here, the ray number one, and the ray number two. They are meeting at A. Okay, see there at A they are meeting. Okay, and when you try to join the principal axis and this, you can see the image is present between focus and 2f2. So here the position is between f2 and 2f2. Again, this image can be caught on a screen, so it is real and inverted. See the arrow mark here, it is look AB, standing arrow mark is there, and you can see here the arrow mark is in downward direction. It means that the image is reverse compared to the object. Okay, so here it's just like the man is standing on his legs. Okay, and when if you try to capture the image of this, then he will be standing in a reverse direction, head will be down. Okay, okay, like this type of image you will get. Okay, when the rays will pass through the lens. Okay, so they are saying it is real and inverted. Inverted means reverse. And again you can see size is diminished. Diminished meaning is, if the object is large, its image will be very small. Okay, image will be very
Very
small.
small.
Very small. Okay, so this is the second type. Next, the third type. The third type is at 2f. So you have to plot the object at 2f. Again, same two rays we have to plot. One is the ray which is parallel to principal axis. So when the ray is parallel to principal axis, we know the first rule. It will pass through the focus. It will bend and it will pass through the focus. The second type of ray is the optic ray, which is passing through optic center. So when a ray is passing through the optic center, it will move undeviated. And again, you can see here the image is formed, that is B dash A dash, and you can see the image is at 2f. So here, see the image was at 2f, object also was at
Yeah.
2f, and the image is also formed at 2f. Okay, so when the object is at 2f in this case, okay, 2f, that is 2f, I said you sometimes it is also called as C. Okay, so when the object is at C or at 2f, its image will also form at 2f. It will form at 2f. Okay, so here the position is at 2f. Again, the nature is real and inverted. The nature is real and inverted, and the
Yes.
size will be same. Okay, the size will be same means whatever the object size is there, if this is 10 centimeter, image will also be 10 centimeter. Okay, so they are saying the size is same. Okay, the size is same. Okay, so you understood all the three, one, two,
Yes.
three, and all the three are, see, they are real images. Which images they are? Real, real, and real. Okay, in first two case,
Mm.
in all the cases it is inverted. In all the cases it is what? Inverted.
Okay.
In first two cases it is diminished, and in the third case it is same size. Okay,
Okay.
now we have fourth type. Okay, the fourth type we will discuss. So the fourth type, that is the, you see here what is happening, the object is coming closer towards the lens. Okay, in first case it was at infinity. Okay, first case it was at infinity, second case it was beyond 2f, third case it is on 2f. Okay, now we will discuss the fourth case. So in the fourth case you can see, in the fourth case you can see there in the fourth case. Okay, so this is the
Yeah.
case number 4. So in the case number 4, see it is between 2f and f1. It is in between 2f1 and f1. Okay, so when it is in between 2f1 and f1, okay, when it is in between 2f1 and f1, see again there is one ray passing parallel to principal axis. It will pass through f. It will pass through f, and then you can see there is a optic center, one ray which is passing through optic center, and both the rays are meeting here at the point A. Okay, so this point A will help us the formation of image, and you can see the position of the object. The position of the object is in between 2f1 and f1, whereas the image is beyond 2f1. Okay, image is formed beyond 2f1. Object is in between 2f1 and f1. Image is beyond 2f2, and you can see the size of the image. The size of the image here, it is large compared to the size of the object. Okay, so they are saying size is enlarged. Size is enlarged, and the image is real and inverted. The image is real and what? Inverted. Okay, so this is the fourth type. Next, the fifth type is when the object is present on the principal focus. Okay, so see, it is present on f1, and f1 is nothing but the principal focus. So when the image is present on the principal focus, again two rays we have to draw. That is one ray which is parallel to principal axis. After passing through the lens, it will pass through the principal focus, and the second ray is which is passing through the optic. Okay, optic center. Okay, and you can see both these lines are parallel. Okay, you can see there both the lines are parallel. Okay, both these lines are what? Parallel, and we know parallel lines, if you extend, they don't meet. Yes, no, do they meet parallel lines?
No, they don't.
They don't meet. Okay, so because of that, the image is very, very enlarged. Okay, so see, you can see there, here they have written size is highly enlarged. Okay, so the size is very large, and then the nature is real and inverted, and position will be at infinity. That is, the rays will meet at infinity. So this is about at f1. Now, see, again they are trying to get the object very, very close to the lens, and you can see the object is now present between f1 and O. Okay, so when the object is present between f1 and O, you can see there the object is here, one parallel ray, it is passing through the principal focus, and then the second optic ray. Okay, but here actually they are not joining. The rays will not join. See, here you can see the distance between the two rays will go on increasing. Okay, and when this will go on increasing, the rays will not join. Because of that, what they will do is they are producing the lens, the rays in backward direction, and you can see the image is formed just behind the object. Okay, just behind the object. Till now, what we were discussing, there is a object, there is a lens, and then there is a image. Okay, so object is on one side of the mirror, object is on one side, and image is on one side. But this is the special case. In this special case, you can see both object, both the object as well as both the object and the image are on the same side. And such kind of images are called as virtual images. What they are called? Virtual
Virtual images.
images. Okay, virtual images. And virtual images, they are opposite of real images. Okay, and these images you cannot catch it on the screen. Okay, you cannot catch these images on the screen. Okay, real images you can observe it on the screen. Virtual images you cannot observe it on a screen. Okay, so such images which are on the same side of the object. See here, the object and the image are on the same side. Such images are called as virtual images. Okay, they are called as virtual images. And
Images.
you can
Yeah.
see the size of the image. The size of the image is large compared to the object. So the size is enlarged. And then they are on the same side of the object. Okay, so these are the 6 points regarding the convex lens. Okay, next we need to discuss the image formation in concave lens. Okay, next we need to
Yeah.
discuss the image formation in concave lens. Okay, did you understand all the 6 types?
Yeah.
Okay, again you need to practice it. Once again, draw it and practice it, and then you need to know the this nature. Okay, position, nature, and size. So you need to write it without saying. Practice it once or twice. Try to draw the image. Okay. You have scale pencil with you now.
Yeah, I do.
First we will discuss and then you can draw one figure. So one of the ray diagram we practice it. So next the second type. So here only two types are there in concave lens. Okay. So one, so you can see first type you can see here. The concave lens we have only two types. In the first type at infinity. So you know no, the difference between concave and convex lens. So concave lens it is curved. The bulged part is inside. Okay. In convex lens the bulged part is outside. Okay. So see whenever the rays are parallel to the principal axis, after they will diverge out. Okay, they will diverge out, and then when you get them back, you can see they are meeting at f1. Okay. So here, what will happen in concave lens? In concave lens, after refraction, they appear to pass through f1. Okay, they appear to pass through f1. Okay, so you can see the position of the image is at f1. Nature is virtual and erect. Why it is virtual and erect? Because object is also on the same side, and the image whatever is formed is also on the same side. See here the image and here is the object, and both are present on the same side of the lens. So here the nature is virtual, and again highly diminished. Object size is more and image size is very less. Okay, so this is the first type in case of what? Concave lens. Okay, concave lens, first type. Next, in the second type, we have second type. You can see the second type. It is beyond 2f. Okay, beyond 2f. So one ray we have to draw parallel to the principal axis. After passing through the lens, this ray is moving in the upward direction. Okay, and you have to show one more ray. You need to extend this ray in backward direction. It will pass through f. Okay, see here. Try to understand.
Yeah.
This is the lens. So this is the lens. So this is the concave lens. So when the ray is hitting this lens, parallel ray, so it will actually go outside. Okay, but when you try to draw a dotted line, so when you try to produce the ray in the backward direction, you can see it is passing through F. It is passing through F. Okay. So the same rule only. The ray which is parallel to principal axis, it will pass through principal focus. So this is the first ray. And then the second type of ray, you can see it is passing through optic center. So the ray which is passing through optic center, it doesn't get deviated. It will
Yes.
directly pass. Okay. So these two types of rays they are using. And both the rays you can see they are intersecting here. Okay, so this is the image. So you can see object size is more, image size is very less. Okay, see AB and then A dash B dash. So A dash B dash is the object, AB OB AB is the object, A dash B dash is the image. Okay, this is the image. This is the image we are getting, and this is the object. So from this we can discuss between F1 and O. The image is formed between F1 and O. Then virtual, because both object as well as image are on the same side. And then size is diminished. Okay, diminished means you can see the image is very small. A dash B dash is very small. AB is very large. Okay, so it is also diminished. Okay, understood. This is about the ray diagrams. Okay, so altogether 8 ray diagrams you have, 6 for convex lens and 2 for concave lens. Okay, so what you do for homework, you practice it. Any 4 you practice it. Okay.
Yeah.
So Sahanya. So out of 6 in the convex lens you practice any 4, and concave lens only 2 are there. You practice both of them. Okay, so altogether 6 ray diagrams. You try to draw it by taking proper scale and all. Okay.
Yeah.
Next, we need to discuss the uses. This is the last point in this topic. We need to discuss the uses of this lens. The last.
Okay.
The uses of concave and convex lenses. So the first use of concave lens. Concave lens uses. Concave lens are used in glasses. Then like your specs, whatever you use. Okay? Such, parents, teachers, one who has eye defect, they make use of what glasses. Okay? So whatever the specs and all you are using, in that they are making use of concave. Then in lasers, okay, and in cameras and in flashlights. These folds also. In
Yeah.
the, they are making use of concave. The convex
Yeah.
lens, there uses of convex lens. The convex lens is used in microscopes and magnifying glass. You have seen magnifying glass? They used to read newspaper.
Yeah.
Yeah. So what will happen in magnifying glass or in microscope? Whatever the smaller object is there, it looks enlarged. Okay. In microscope, you can see a very tiny object. It will. Okay. If you see a ant in microscope, it appears like cockroach. Okay. So its size will what increase. Okay. Microscope and magnifying glasses, they are making use of convex lens. Convex lens is used in cameras. Okay. Again, convex lens is used in
No.
hypermetropia. Okay, hypermetropia, correction of hypermetropia. Two types of diseases are there. These are eye defects. Hypermetropia and hypermetropia. Two types are there. In that they make use of convex lens. So in one case they will use convex lens, and in other case they will make use of concave lens. Okay. So these are the uses of concave and convex lenses. Yeah, exercise 5. Try to solve the exercise. Some questions I will ask you. Okay. So just try to answer. We will try to discuss.
Okay.
The first question in your book is light can travel in. So light can travel in dash. The options are air only, vacuum only, none of the above, all the above.
Okay.
This option is right. Light can travel in. So the light doesn't require any material medium to travel. So it can travel in all. It can travel in air, it can travel in water, it can travel in vacuum, it can travel in all the things. So next, second question. The characteristics not seen in the image are formed by plane mirror field. Okay, plane mirror field.
Okay.
That is see diminished. Okay. In plane mirror, as you appear, the same image is formed. Okay. The object and image both will have the same size. Okay. It will not be diminished. Next, converging light rays is seen. Okay. Converging lines means bending towards the focus. So these you can see in convex lenses. This lens is convex lenses. The convex lenses are also called converging lenses. What they are called? Converging lenses.
Okay.
The concave lenses are also called as diverging lenses. So they are called diverging lenses. Then the characteristics not seen in the image found by concave lenses. So, it cannot be obtained on the screen. We discussed in case of concave lens, all the images are what virtual images. Okay? And since they are virtual images, such images they cannot be obtained on the screen. In the spectrum of light has how many colors? How many colors are there in spectrum of light?
There are more than one. No. There are,
7 colors it has, no?
yeah.
Okay, whatever the rainbow you see is nothing but light. Okay,
Oh.
so it has 7 colors. How many colors it has? 7 colors. Okay. So we will stop here, and in the next class, ma'am will begin with the next chapter. So for your homework, you practice all those ray diagrams once again, and
Oh.
the exercise part you try to solve it. If any
No.
difficulties are there in the next class, you can ask from the exercise. Okay.
Okay.
Okay. Bye. Take care. Okay.
Thank you.